So students, we are here to see the classification of the crystalline solids or true solids. True solids are classified in the following way as shown in this divisional chart. First comes the ionic solid, then comes the molecular solid, then comes the metallic solids, and then comes the covalent or network solids. Now here, this thing that is molecular solid is again classified into three parts. First, non-polar molecular solid. Second, polar molecular solid. And third is hydrogen bonded molecular solid. So ionic molecular solid, here are the examples. Any ionic compound, the best example you can take is NaCl. You can take CaCl2, etc. So these are the ionic compounds which exist in the solid crystalline form are the examples of this. Okay, done. Now coming to this metallic solid, these are basically the metallic structures, the pure metals. The metals already I have mentioned in the classification that metals are also crystalline solids. So these are some of the examples. Obviously all the metals fall in this class. So some metals are written, that is iron, copper, silver, magnesium, etc. So these are some of the examples of metallic solids. Now covalent or network solid. Now the name suggests that these are giant network compounds. Obviously these are the covalent compounds. Some of the examples of these compounds are been given. It is silicon carbide or carborundum. Second, the allotropic forms of carbon. One is diamond. It is a giant network solid. Again, the second one is graphite, another allotropic form of carbon, that is an example. Aluminum nitride is also an example, and so is silicon dioxide, which you call sand in the common language. Now coming to this non-polar molecular solid, see, this is also covalent, this is also covalent. These are simple molecules, but these are giant networks. So that is the reason why two classifications have been made. And last but not the least, the difference between these two classes, when we see, it just gives a chalk and cheese difference. So things are totally different. That is the reason why it is classified in some other way. Now coming to the molecular solid, first comes non-polar molecular solid. Now those solids will always contain the constituent particles as non-polar molecules. See, noble gas, argon. You can also take the example of helium, doesn't matter. You take the example of CCl4, you can also take the examples of CF4, something like that. So these are all non-polar constituent particles that obviously the solid state gives to this. Now these are some polar molecules. The molecules which have permanent dipole moment, these molecules in the solid form is an example of polar molecular solid. And hydrogen bonded molecular solids, this directly means that when these are in the form of solids, there exists the hydrogen bonded system. That means the hydrogen bonds are present. Ice, solid ethanol are two other examples. Now here I will come to the characteristic properties of each and every molecule. I will come to the characteristic properties of each and every type in the different video. So this is the basic classification of the solids.